Hello everyone, let's solve the problem number 55, jump game, right? So what the question states here, we are given an array nums. You can clearly see here, we are given an array nums, right? So where each element represents the maximum jump length. So each element here represents maximum jump length, means uh, how far we can jump, right? So 2 steps, 3 steps at a time, 1 step, 4 step. So just keep this in mind. Where each element represents the maximum jump length, you can take from that particular index. Starting at the index 0, determine whether it's possible to reach the last index or not. We have to start at the index 0 and they have strictly mentioned that we have to start at the index 0 and we have to determine whether it's possible to reach the last index or not. So that's what they have asked in the question. Easy to understand, right? Let's come to the first example here. So here in this case we have 2, right? So we have 2 here. Let's either we can jump 1 or 2 steps at a time. Maximum length is 2, so let's jump 1 at a time, and we have 3 next. So let's jump, either we can jump this one step or 2 step or 3, right? So let's jump 3 step at a time here. So we have reached the last index, right? So in this case it is possible, so we have to return true. So if it is possible, we have to return boolean value true in that case, right? So this is fine. Let's come to the second example here. We have 32104. So when I jump 3 steps at a time, I'll go to 0 here in this case, right? So if I jump only 1 step, then if I jump 2 steps, then also I'll go to 0. So here if I jump 2 steps, then also I'll go to 0. If I jump 1 step here to 2 and then 1 step, then also 1 step, then also I'll go to 0. It is impossible to jump to the last index. Nothing but value. We are having 4, right? 0, 1, 2, 3, 4. This one, 4th index I'm speaking of. 4th index, and the value is also 4 here, right? So this index we cannot jump, right? It is impossible to jump to the last index here in this case in the example 2. So in that case we have to return false. Means we will always arrive at the index 3 no matter what, right? Here in this case, that's what in the explanation they have given. So its maximum jump length is 0, which makes it impossible to reach the last index, right? So in this case we'll return false. So I hope the examples are clear, right? So they have given wonderful examples just for the sake of understanding here, right? So I hope the question is completely clear. What we need to do is completely clear as well. First, let's discuss the approach, followed by the edge cases one by one, and then finally let's write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So the first thing that we need to keep in mind here is we'll be going with the greedy approach, right? So we'll be going with the greedy approach. So I have considered the same first example that they have given in the question, so that it will be easier to understand the approach, right? So first what we'll do, we'll jump one step at a time, and then we'll hop from 3 to 4, as the maximum length is 3 here. We can jump 3 steps at a time, right? So here in this case we'll directly go to 4. So as we can reach the last index, we have to return true in this case. So that is the reason we have returned true, boolean value true here. So this is fine. So just keep this in mind that we'll be going with a greedy approach, right? So here, as we are done with the this one first example, we have considered, we have already discussed the first example here. Let's go with the step-by-step approach here, or explanation, right? We will start at the index 0. Value is basically 2 here in this case, right? So we'll start with index 0. The value is 2 basically. Can jump to index 1 or 2. We know this one, right? So we will go to index 1. We will go to index 1. The value is basically 3. Can jump to index 2, 3, 4. So we have come here. This currently now we have 2, 3, 1, 1, 4. We have jumped here, right? So here can jump to 2, 3 or 4. So jump directly from index 1 to index 4. That's what we did. So again we are considering the same thing within the approach, right? So here we are going from 3 to 4 basically, right? So here in this case last index is reachable, so in this case we have to return 2. So the output that we got here is true, which is equivalent to the output that they have given for the first example, right? First example. So in this case the approach works absolutely correct. So as we are completely familiar with the approach, let's quickly discuss the this one edge cases, right? The first edge case is for the single element. See here we have only one element, so we can directly consider true here in this case, right? So we are already at the index, at the last index here in this case. No jump is needed, so we will return true. Let's come to the second edge case here. First element is 0, more elements ahead. See this one I'm speaking about, that is 0 1 we have, right? So we cannot move forward from index 0, right? So we cannot move forward from index 0 here. We have to move forward from here, right? So we have 0 here, the value itself is 0. We cannot move forward from index 0, so we have to return false in this case. Let's move on with the third edge case here. Mid array blocked by 0. So here we have value 1 0 1 0, right? So here we will reach index 1 here in this case. One step at a time we can move 0. We cannot move ahead of this one. We have 0, value 0, so we'll return false in this case, right? So here we'll reach index 1, but we will be stuck due to the 0 jump here. In this case it will be false. Let's move on with the fourth edge case here. Jump directly over zeros. We have 2 0 0 here. We can directly jump from 2 to 0 here in this case, right? We can't reach the last index, so we'll return true in this case, right? So let's move on with the fifth edge case or the final edge case here. Step by step jump basically works here. See, one step at a time, here again one step at a time, as we have the value 1, again one step at a time, again one step at a time. So we have reached the last index here 0, so we will return true in this case. This works, right? So these are the 5 edge cases that we need to consider here. The first edge case is for the single element. The second edge case is for the first element is 0, more element ahead, so more elements ahead. So the third one here in this case is mid array blocked by 0. The fourth edge case is for the jump directly over zeros, and the fifth edge case is for the step by step jump works, right? So here now we are completely familiar with the approach as well as the edge cases. We are good to write the code. Let's start writing the. So here the first step is we have to keep track of the furthest index that we can reach, right? So I'll just give here in this case int this one. I'll just make use of the variable name max reach and initialize this one to 0. This is fine. So let's go with the traversal or iteration here. In this case I'll just go, we have to traverse through each element in the array, right? So I'll just go with I equals 0, I less than length of the nums, and let's increment the I here. This is fine. So within the for loop, what we have to do, if the current index is beyond the max that is reachable, means if the current index is beyond the max reachable, then we cannot proceed. So for that, let's write the simple if condition. We know this one, right? By the by approach. So I'll just give here if I, so this has to be greater, right? Means if current index is beyond the max reachable, then we cannot proceed. So I greater than max reach, this one. Let me copy this one and paste it over here, max reach. Then what we need to do, we have to return false in that case. So this is fine. So the next step here is we have to update the max reach from the current index. Means I'll just go with here max reach equals mat.max. Whenever we find the max, we have to update that one, right? Means we have to update the max reach from current index. So I'll just go with max reach here, comma I plus nums of I. This is fine. So the next step here, if we can reach or go beyond the last index, means if we can reach or go beyond the last index, then we have to return true in that case. That's what they have asked us to find basically, whether we can reach the last index or not, right? If we can reach or go beyond the last index, then we have to return true. So here in this case, if max reach is greater than or equal to length of the nums minus 1, means the last index or beyond, so then we have to return true in that case, right? This is fine. So the final step here is if the loop completes, then it means we have reached the end, right? So in this case we have to return true. If the loop completes, it means we can reach the end, then we have to return true. So let me do one thing here. Let me format the code once and let me hit the run button. So this is it for the code. I hope this works. Let's see what happened here. So yeah, yeah. So the sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases. Let's see. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. Let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is greedy. We know this one, right? So the approach that we went with here is greedy. So overall time complexity would be big O of n in this case. So why it is big O of n in this case? Because we are iterating through the array once. The line number 5 I am speaking of here. This one we are iterating through the array once. Means linear paths, right? So overall time complexity would be quite obviously big of n in this case. So what would be the space complexity here? The overall space complexity would be big of 1. Why it is big of 1 here? Because we are making use of only one variable here. This one you can clearly see, max reach, right? So we are making use of only one single variable and we are not making use of any extra space other than that, right? So overall space complexity would be quite obviously big of 1. So the time complexity is big of n and the space complexity is big of 1 for the code that we have written, right? So I hope the complexities are completely clear and I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.